Okay, students, in this lesson we're going to talk about compound inequalities. In the previous lesson we talked about just inequalities, a single inequality, and how to solve it and graph it. So we are going to look at compound inequalities. Well, compound inequalities, you're going to have two different types. You're going to have one set that is separated by the word and sometimes that can be in a between statement. So for example, number 2 right here, that would be considered an and statement because it means that 3x minus 1 is greater than negative 10 and it could be less than 14. So when you have an and statement, what you're going to do is you're going to solve it as two separate inequalities, and then when you draw your number line, you're going to shade where they cross, because it needs to satisfy both, and so you will shade where they cross. We'll do an example in just a minute. If it is separated by an or, then that means that it satisfies one or the other, so you're going to shade both of them. So it satisfies one or the other, so you will shade both. Okay, so let's go ahead and work an example. Number 1, it says 3x is greater than negative 27 and 2x is less than 12. So go ahead, they're already separated into two single inequalities, so let's solve both of them separately. On the first one, we are going to divide both sides by 3, because we need to get the x by itself. So when we do that, x is greater than negative 9. Now remember, do I need to switch the inequality? No, you only switch the inequality when you divide by a negative or multiply by a negative. So this is one of my inequalities. Now let's go over here to the other one. 2x is less than 12. I'm going to divide both sides by 2. I do not need to switch the inequality, so x is less than 6. So here it is. X can be greater than negative 9, and x is less than 6. So let's see how we're going to graph this. We are going to draw a number line. We need to put negative 9 on there. Now remember, negative is over here, so we're going to put negative 9 on the left side. And 6 is going to be to the right of the negative 9. We're going to put it way over here. I also want you to have the 0 on there because I need to make sure you understand where the negatives are and the positives. So the 0 is going to be in the middle somewhere of negative 9 and 6. Okay, now we need to put our open and our closed circles. Well, greater than is open and less than is open. And if you've forgotten how to determine whether it's open or closed, open is when there is no line under it, and closed is when there is a line under it. So at negative 9, I'm going to have an open circle. It's open because negative 9 is not included. It says x is greater than negative 9. So I'm going to shade in the greater than side, which is to the right. Now right now I'm just going to draw a little shading. And now let's go over to the x is less than 6. So at 6, I'll have an open circle again because 6 is not included. Everything less than 6 is. So on the left side is where I'm doing my shading. Now, if we want to shade where they cross. So if I continue drawing this shading, they're going to cross each other. And so the inside is just the part that is shaded. One other thing I want you to recognize is that these inequalities right here could also be written this way. What is the smallest number? Negative 9. So I'm going to write that first. I will always have less than signs with x in between. So x could be greater than negative 9. Notice that it's opening up towards the x, which is what I want it to do because that's what it did over here. And but then also x is less than 6. So I could put that onto the end here and say that it's less than 6. So now what this means is that x is between -9 and 6. So you might also see it written like this. I want you to get in the habit of writing your inequalities like this if you can. So on the and statements, it should write like this. If, for example, and we'll do one in just a minute, where the x is not between two numbers, then you'll see what happens. Moving on to number 2. If you notice on number 2, it's already put together. So we need to get this x by itself. So we need to get rid of everything that is by that x. So we need to get rid of the -1, and we also need to get rid of the 3. You can go ahead and separate these out into 2 separate inequalities, but I'm going to go ahead and leave them together. So right now I'm going to add 1 to every side of the inequalities, which means there's 3 sides, so you're going to have to add it to all 3 sides. -10 plus 1 is -9. Go ahead and bring down your less than or equal to sign. But now because these cancel, I have 3x in the middle, and then it's less than 14 plus 1, which is 15. Now I need to get rid of the 3, so I need to divide everything by 3. -9 divided by 3 is -3, and that's less than or equal to, those cancel, so I have x, and that's less than 15 divided by 3 is 5. Okay, so here's my inequality. Now we're going to graph it. So we'll draw our number line. And I have a -3 on my number line. I have a 5 on my number line, so that would be over here. And then in between -3 and 5, somewhere in here is 0. Make sure you put the 0 in the correct place. Okay, so let's go ahead and put our circles. So at -3, it says it's less than or equal to. So -3 is included in this, and that's why there's going to be a closed circle, because it's saying that -3 is included, so we need to go ahead and close in that circle. At 5, we have a less than sign. Well, less than means that x could be less than 5 but not equal to, so it's got to have an open circle. And then we shade what's in between those 2 sections. So when you have this between statement, here's how you would read it. If you were to say this to somebody, you would say that x lies between -3 and 5. Okay, so if you hear somebody say that, that's what they mean, is this statement right here. Okay, in this next problem, I want you to notice something. In the previous one that we just worked, so that one's over here. Let me find it really quick. Number 2 is right here. In this one, if you notice that both of these are less than symbols. That's because when you're reading from left to right, this number over here should be the smaller number, because it goes smaller all the way up to the bigger number. Okay, let's look at number 3 now. When you're looking at number 3, these are not less than symbols. These are greater than. Is -5 greater than 15? No, it is not. We need to go ahead and switch this around. Okay, so we're going to just totally turn around, and actually if you notice that from the very beginning, that -5 is not greater than 15, and that's what it's saying here. This is actually going to turn out to be no solution, but let's go ahead and turn it around, because I want you to get in the habit of turning it around to where it's less than all the way across. So if I'm completely turning this around, I'm going to have my 15 over here, and notice that it is pointing to my 15, so I need to make sure that it is still pointing to my 15. And then I'm going to have that 5x in the middle still, but then I'm going to have my -5 over here, and if you notice, this is opening up towards the -5, so I need to make sure that it's opening up towards the -5 here. Now let's just see what happens as we solve this. I'm going to divide everything by 5. 15 divided by 5 is 3. And that's less than, this cancels, x, and it's less than -1. Okay, again, if you were to go ahead, like let's say you just weren't thinking about it and you were just working this out without really even thinking, but now you go over here and you graph it, well, 3, I'm going to put it on this side, and -1, I'm going to put it over here on this side. And what this is saying is that x is greater than 3. So it's over here, right? And there's an open circle. But x is also less than -1. Well, less than would be over here, an open circle. Okay. Can that happen? Can it be greater than 3 and less than -1? No, because it never overlapped. So this is what we call a no solution. It's not a true statement. We cannot make it work. So this would be no solution. And you'll recognize this because the number that's on the left side over here should always be the smaller number, because we're going here less than a bigger number. So this one should be little, and the number on the right should be big. And if it's not, there's something wrong with that picture. Number 4. Notice from the very beginning that this is an or statement. So let's go ahead and solve each one of them separately. So in the first one, we're going to add 2 to both sides. We have 4y is greater than or equal to 16. We're going to divide both sides by 4. So y is greater than or equal to 4. I didn't have to flip my inequality because I did not divide by a negative. Over here, I'm going to add 4 to both sides. First, 3y is less than or equal to -9, and then divide both sides by 3. Y is less than or equal to -3. So I'm going to bring down that or statement. Y can be greater than or equal to 4, or y can be less than or equal to -3. So let's see what that looks like when we graph it. I'm going to graph this one first. So y is greater than or equal to 4. Here's 4 on this side. Greater than or equal to is going to be a closed circle. And then greater than is on the right side. So here's what this one looks like. Now I'm going to graph y is less than or equal to -3. Well, -3 would be over on the left side on a number line. Less than or equal to is going to be a closed circle. And then less than would be over here. Okay, so because this is an or statement, you want to shade both of them. So this is going to be what the answer is. Here's our inequalities, and here's our number line. I want you to keep in mind that when you have an or statement, it never combines. So this kind never combines, meaning we would not want to rewrite this as a between statement. Okay. Okay, the last two problems are going to go rather quickly. They've already solved for the variable, so all we have to do is graph it. So let's draw a number line. And it says x is greater than -5. So -5 I'm going to put here. And it's greater than, so I'm going to have an open circle and greater than. Okay. The next one says x is greater than -6. Well, which side of -5 is -6? Well, my 0 would be to the right of it. And if I'm going from 0 left, I'd go -1, -2, -3, -4, -5, and then I would have a -6. So that would be over here. -6, it says x is greater than -6, so now I'm going to put an open circle again, but greater than -6 is going to cover up that -5 and go this way. Okay, so in this particular example, because it can be greater than -5 or greater than -6, you're going to want to include this graph. So at -6, I will have an open circle. but it can be anything to the right of it. And that way I'm including the x being greater than -5, or it can also be greater than -6, so I have to include both because it is an or statement. So this would be your final graph. Last but not least, x is greater than 0 or x is less than 4. Okay, so let's draw a number line. Let's put our numbers on here. So we have 0. We also have a 4, which would be over here. Now let's graph. X is greater than 0, so greater would be an open circle, and greater than would be this way. Okay, now let's graph the 4. X is less than 4, so open circle, but now it's less than 4, so it's going to be this way. Should have done it in different colors so that you could see the difference. Okay, there's my x is less than 4, and this part right here is my x is greater than 0.